Ladies and gentlemen, hello and welcome back to dubious engineering. I want to take you through my e-bike build. I've done it on a budget. It's cost me about £250 for the Tongcheng 250 watt motor and computer assembly. The motor drives straight through the bottom bracket of the frame there, so you don't have hub motors on the front wheel or the rear wheel of the bike, which makes wiring and all that kind of stuff quite a lot more simple, and actually it gives the bike a more natural feel when you start riding as well. Connected to the motor assembly, we also have a large 36 volt 15 amp hour battery that I've fitted to the frame as well. I think the important thing is you need to understand how this rides, how it feels, and I'll tell you, it feels good actually. It really does. It works really well. I'm going to have a thumb throttle for it very soon, which ultimately means that it's just going to be twist and go. So the great thing about the Tongcheng motor is it has torque sensors on the cranks, so as soon as you start pedaling, it immediately brings on the assist. I'm really happy with the way this build went. There were a few little problems that I needed to engineer my way around, but nothing was a real showstopper. We've got a road bike frame, we've got hybrid wheels, so they're not big knobbly mountain bike wheels, but at the same time they're not little knife edge thin racing bike wheels, so they're good, just sort of all-purpose wheels on here, which for me is absolutely magnificent. On top of that, I've got a big sprung-loaded padded saddle so your bum doesn't get too sore. We're going to take this bicycle here and we're going to go ahead and fit this Tongcheng central motor in the bottom bracket here, and we're going to have to take out the pedals first, so we've got a special tool to do that, this guy right here. Then we're going to have to pop out all the bottom bracket assembly. There's another special little tool that you need to do that with, that's this guy here. Eventually we'll end up with a battery in here as well, maybe do a bit of wiring, but this should really get us from A to B pretty quickly as soon as we've got that done. When we fit this motor, we're going to have to get rid of the central derailleur here. I'm also going to have to move my emergency pump. And then some of the other things that we might have to negotiate are the likes of the cables that run down the tube here. So I don't know how we're going to figure all of that out yet, but we will do. So let's just have a quick look at the Tongcheng motor. So in the kit that I purchased then was the Tongcheng motor, a little trip computer, some fitting bracketry, some speed detection equipment, also a second controller which gives you the ability to be able to put the controls on the handlebars, some cranks, a fitting tool, and even a couple of cable ties. So our first job is to go ahead and remove these cranks here. So there's a little plastic cap that pops off quite easily. Once you've done that, you should then be able to get a standard socket. Remember, righty-tighty, lefty-loosey. There we go. So the next part of the process here, you're going to need to use a crank puller tool. This is one of the special tools that I mentioned earlier. And ultimately what this does is it puts a little bit of pressure on the center part there and pulls the crank off. So what we can do is just go ahead and screw that carefully into the crank. You need to make sure that you don't cross thread it. There we go. And once that's on, just put it in finger tight. And then this center part here screws in. The rod in that center part there just goes ahead and pushes the crank off its center pin. So now what we do is we just literally just use a spanner to tighten up that nut, and as you tighten that nut, that should lever the crank off the assembly here. You're gonna laugh, guys and girls, so just sending a message to the company that sold me the crank puller. It stripped its threads in half a heartbeat. As you can well imagine, that's really quite irritating. Hopefully you can see this, but ultimately, look at that, yeah? The thread in it has just disappeared in a heartbeat. This has held up well, no problems at all, but the internal thread on this guy here has just literally fallen apart. So whilst we're here, let's just have a quick talk about this TSDZ2 motor. This is a 36 volt 4000 RPM motor. It's got 42 tooth gear on the outside of it. It's got a couple of little plugs on it, and those are for the controllers, and then it has a couple of cables that go into it in order to drive the motor. Now this particular motor is, I believe, a 250 watt variety, and you can get these up to, I think, 750 watts. Here's the computer. Not a lot to see when it's not plugged in and turned on, so we'll have a more detailed look at that computer once it's on the bike and in operation. Once you've got those cranks off, you're then going to need another tool, and this is like a spline tool, and the spline tool will go in here to remove a large bolt which holds the bottom bracket bearings in. So now we take the chain off, there we go, and we pop the bottom bracket bearing assembly out. Okay, right, I managed to get this one off as well. I've been a bit controversial here. I've used a hammer and a flathead screwdriver to effectively lever them off. You just keep tapping it and rotating it. Anyway, bit naughty. Now, one thing that you need to remember is the splined nut on this side rotates in the opposite direction. It's actually righty, untighteny. So now hopefully we should be able to remove the bottom bracket bearing. What do you reckon is going to be in here then? Ah, look at that, a nice Sunrace bottom bracket bearing. You may also notice that whilst I've been doing this, I also took the opportunity to remove the derailleur here as well, because ultimately we won't be using the derailleur. So I've gone ahead and removed that, which has freed up one of the cables through here. I'm a little bit nervous that those cable guides are going to interfere with the motor. Let's see if the motor fits. Again, the motor installation is relatively simple. You just unscrew this little splined nut here, and you get yourself an Allen key, and you've got a couple of little bolts here and here that we need to undo, which will release this bracket, and then this guy will slide into the bottom bracket just like that. So as I suspected, when trying to fit the motor, unfortunately these plastic cable guides here foul on the motor body. So I think what we're going to have to do is reshape these. Okay, so a little bit of dremeling later, and now we have a nice little channel and our gear cable runs through there quite well. Takes a little bit of gentle coaxing and cajoling, and there we go. So let's not forget now that we need to refit the bracket here with the appropriate little spacers. So we'll just put the bolts in place, get that bracket fitted. Once this guy's in place and tightened up, we can then fit the threaded nut. Once that's all in place and tightened up, you then have a special tool here which gives you the ability to be able to do up this splined nut. And then finally, to prevent any potential rotations from taking place, there's a clamping bracket here which fits underneath the V of the forks and then also bolts in to the body of the motor, and that'll stop any potential torque twists as the motor turns on and tries to help you. Another sort of minor issue here whereby Mr. Tongsheng would like to stop my wheel rather than help my wheel rotate. As you can see, as you tighten this bracket here, it pulls the motor down into position. The bracket itself, unfortunately, contacts the rubber of the tyre. So what we're going to do is we're going to manufacture just a little shim to keep the top part of this bracket a little bit further away, giving just a few millimeters worth of clearance in here, so that the wheel, the tyre, doesn't cause a problem. If we decide that we want to put new tyres on here, which we will do at some point, there's going to be a little bit of extra rubber on there. So we want to make sure there's a little bit of clearance in for that. These tools with the universal joint make jobs like this so much easier. Definitely worth investing in something like this. Look at that. Done. Awesome. Having identified that I need a secondary spacer, Mr. Tongsheng very kindly gave me a tightening and removal tool. Well, that appears to have gotten a little bit shorter, because we're going to go ahead and make our secondary spacer out of his tool, as it is of a substantial thickness. Righto, good enough for government work. So making some really good progress, but I ran out of big enough hex wrenches. You need an 8mm hex wrench to be able to get these crank bolts out. Anyway, let's get some cranks and pedals on this bad boy, and we can fit a chain, and maybe we can, maybe we can actually take it around the garden. Don't forget, people, you need to remember you've got a right crank and a left crank. You're going to need a little bit of muscle for this job. Get your 8mm Allen wrench, get it biting, and as soon as it's bitten, you're going to have to give it some beans. Yeah, and that will put the crank nicely into position. They're slightly tapered shafts, so you've got to give it a little bit of beans. There we go, about that. Right, look at that. We got a wheel that spins and everything. The problem is we've got no pedals on here. Anyway, good news, we've got plenty of room here now behind this little bracket which I've fitted, and I've put my own little design spacer which was made out of the tool, the tightening tool. So yeah, looks like we've got Mr. Tongsheng fitted. Right, let's get some pedals on here. Let's not forget, again, you've got left and right pedals. One pedal does clockwise, and the other one does wise clock. So once we've got the motor fitted, then it's time to start figuring out quite how all of the redundant gear shifters, hand grips and brakes, all that kind of good stuff comes off of the handlebars here. And then we need to fit the new computer. Then we've got to route cables and we've got to route batteries. I'm just removing the redundant parts first. I had an old cycle computer on here. Well, that can go away, don't need that anymore. I've also got some lights. I'd like to hang on to those, so we'll figure out quite what we're going to do with those in a second. And the gear shifter that I had on here for the derailleur that I removed, there's no point in keeping that on here. Might as well put that on eBay and see if we can get a couple of quid for it. I was just trying to figure out quite how I wanted to fit the computer on here, and clearly what you do is you undo this and this should open up, and then you can sort of clip it over the top here. The little plastic lugs that are used to fit the computer are a bit crappy. They come split, and as soon as you pull them they have a tendency to split and break, unfortunately, like that. So I've managed to break one. Anyway, We'll keep on trucking, ladies and gentlemen. So, so if you think fitting a Chinese motor to your bike is easy, just consider this is night one, and we've got as far as actually fitting the motor and starting some of the electronics. This is a 15 amp hour 36 volt battery, and trust me, it's got plenty of beams. It's probably just borderline a little bit too big, but I'm really happy with the way the Tongcheng motor is working and the way it assists me when I'm cycling. It really does take an awful lot of the effort out of cycling. Another thing I had to do was fit this speed sensor here on the back wheel. None of this was particularly difficult. The speed sensor was just a case of cable tying it in place and plugging it into the appropriate connector into the drive circuit for the Tongcheng motor. And the battery itself, I put a couple of little Anderson power pole connectors on there so that I can disconnect it rather than using the bullet style connectors which came with the Tongcheng. And a weird thing is this particular battery comes with an IEC mains type connector, and ideally I'd like to find one with a right angle jack on it instead of this one that pokes out. Though that said, I haven't caught my knee or my leg on it when I've been cycling. In fact, I haven't even noticed that it's there. And the battery itself is mounted literally with one screw and lots and lots of cable ties, but it's absolutely solid. I've got it cable tied at the top here, and ultimately the battery really is for a back loader. It shouldn't be fitted into this frame, but I just wanted that higher power battery. The weight of this bike, even with the motor and that large battery on it, isn't too significant. I'm okay with it. It actually works quite well. I fitted this lovely seat here, all springy and padded, because ultimately this is a hard-tailed road bike frame and there is no suspension on it at all. So to have that little bit of padding is lovely. So the other thing that we should probably have a look at is the computer. Let's go ahead and turn on the battery, and then let's turn on the computer. And as you can see, the computer went ahead and booted up there. I've done all of about 6 miles on this at the moment, and 5.1 miles was my last trip. My average speed was 12.7 miles an hour, which is pretty good considering it was in traffic. But ultimately then you have eco mode, touring mode, speed mode and turbo mode, and that's the level of assist that the computer gives you. So on the handlebar just here is a second set of controls, so you don't have to take one hand off the handlebar in order to control the computer. You can do all of that, as you can see here, from this set of separate controls. One thing you can do with this computer, so if you press and hold these two for 4 seconds, 1, 2, 3, 4, and then press this 1, 2, 3, 4 times, you get into an engineering mode, and in here you can indeed go ahead and change all sorts of crazy settings. Currently then the speed limit is set to 25 miles an hour and it's on, and what we can do is we can turn that speed limiter off. That's all looking pretty good. I'm loving the computer. The computer does exactly what it says on the tin. I think the important thing now is to get it out there and give you guys a bit of an idea of how cool, how much fun this bike really is. Ladies and gentlemen, so less than £400, a battery and a motor for a bicycle that happily does 20 miles an hour with not very much effort. Absolutely magnificent. So I'm going to make a point of using this bicycle quite a lot more, instead of using the van and starting the diesel engine and driving around. And don't worry, I'm not turning into an eco warrior or anything like that, but I'm actually enjoying riding the bike, and I love the fact that it works so well as it does. Great news! Up on top of the shed are two large solar panels, and in my pocket I have here a very special little PCB, which is basically a boost converter PCB, which takes the 12 volts that I'm storing up in my shed here and converts it to 36 volts charge voltage. Well, in fact, you need 42 in order to charge the battery. But ultimately, this bike is now going to be charged by solar power. Anyway, thanks ever so much for watching. Take care. Have a wonderful week and weekend. Please make sure you give us a good thumbs up. And if you haven't subscribed already, go ahead and do so, and we'll catch you in the next one. Take care, peeps. Bye for now. Thanks again.